Where are you going? Yes. Can I borrow your book? Eventually, I just bought another one. Because apparently mine's never coming back. Sorry?
Number 63.
Oh, you're on the right page? Molly is making strawberry infused water. Yeah, sure, we'll say strawberry, Molly. For each ounce of strawberry juice, she uses 3 times as many ounces of water. Okay, so what we're about to get into today are the word problems associated with these things. So we're going to do some examples, and then I want you to try that problem again. We haven't done an example word problem that kind of uses this stuff yet.
Yeah, I was like, what?
Yeah, we're going to do the word problems on this one, yes. Cool. Okay. Well, first I want to make up some, and then we'll tackle. Put that down. It freaks me out when I see that.
Can't just make stuff up.
Yeah, hey, here we go. So let's say we're at a carnival or something, 3 hot dogs and an order of fries. God, I'm hungry. Why did I do this? 3 hot dogs and an order of fries. Let's say that costs $5.
Sounds like you starved yourself.
Yeah, you don't want to know what to think of. And then if instead you got 2 hot dogs and 5 orders of fries, that would cost, oh man, I forgot what I said here. Oh yeah, $5.50. So how much does each cost? This is a classic example of a 2-variable problem. It's definitely different than a word problem we've done before. It has a different feel. There's no Frank made 2 less than 3 times. There's none of that shit in here. There will be in another problem we do, but not in this one. This one's a classic system of equations word problem. What letters do you think I'm going to use to represent my unknowns?
H and F.
Shit, yes. H and F, yes.
Ha! Get it.
So how would I represent this first?
3/8
3 H's, 3 hot dogs,
plus
and 1 order of fries
equals 5.
equals 5. So that's one equation. What about the second equation?
2H plus 5F.
Plus 5F.
550.
Oh boy, Jeff. There's a 5. Oh, there's 5s all over this damn thing. Shit. Alright.
That sounds easy.
Yeah, and then you just squish the 2 equations
And
together.
now you could do it. There's 2 different ways you could do this. If I said you must use substitution on this, what would you do? I would substitute that problem for a different one, Jeff. No. I reject your reality.
Substitute.
Substitute. Yes. So which letter is the easiest to solve for in the whole thing? That F right there. Because when I solve for it, I'm not going to get fractions. I'm not going to have to divide by anything. So if I solve the first one for F, what do I get?
Negative 3H plus 5 equals F.
Yeah, I subtract 3H, so I get F equals 5 minus 3H. Is that cool?
Yeah.
And then how could I utilize that?
Put the F into the bottom.
Yeah, I know F is this, so I can take that and plug it in the other one. Put it, the F in there, yes.
Could you also put it back into itself so now it's 3H plus 5 minus 3H equals 5?
This is an example of circular logic. Right? This is, if you plug it back into itself, I am me. Me am I. I have gotten nowhere. All right, so you never want to plug something back into itself. If you did, you'll get like 5 equals 5.
Okay.
And it doesn't tell you anything because you're using one piece of information with itself. So of course, that's not going to get you anywhere. I've got to use, so I'm glad you said that. Be really careful. You've got to make sure that you plug one thing into the other. You've got to use both pieces of information. And just from a physical standpoint, that makes sense. I'm collecting clues. I'm going to use all of them to figure out who murdered somebody. Right?
The murderer
I got
is the
this one, I'm
murderer.
going to use this one piece of evidence 5 times, and it'll help me know. You need more evidence.
Because like you said, if you plug that back in, it'd be 5 equals 5.
Yes.
Yeah.
And which would not tell you anything. Yeah. All right, so how does this look now? 2H plus
5 times
5 times 5 minus 3h, because I'm replacing f with what it is.
Equals
It's
5.
5.5. And then you just solve.
And then I just go to 10, right? So let's see, 2h plus 25 minus 15h, 550. So I get negative 13h. And if I subtract 25, I get negative 2050, right?
This is really a messy problem.
1950. Say what?
This is a messy problem, Jeff.
Say what? Yeah, I think I screwed up something. Oh well.
I mean, it's gonna work out, but it's just icky, you know?
It's not
Looks
gonna
like
go
you
anywhere
did it.
It's
nice.
just icky.
How did I mess up there?
By making
Let's
the
do it
550
anyway.
a decimal.
That should work out. Yeah, yeah.
$1.50
So
per
1950
top?
divided by 13? $1.50, okay. That's what I wanted it to be. So if you divide by 13, negative 13, you do get $1.50. How do you figure out what the fries are? Yeah, you know fries is 5 minus 3 times hot dog price. 3 times that is 450. 5 minus 450 is 50 cents.
Jeez.
That's pretty cheap nowadays, decent for fries.
Yeah,
Do you
what is it,
notice
the
how I said
50s?
nothing about how big these are?
No, that's like the 80s, 50 cents for
Oh, right, like
Here's the actual size hot dog.
$30.
And then you get 2 fries. My artistic skill.
Back in my day.
Question.
Yes.
So the reason why you got negative 13 is because,
2h minus 15h.
oh,
It's negative 13h. And then subtract 25, and that's how I got there. With somebody's help.
So what helps me with minus problems is anything on the right side of a minus symbol is negative. That's how I see it.
Yeah. As long as it's directly connected.
So if it's
to
like
it.
2 minus 12, the
Oh,
12
sure,
is
of course.
negative.
Subtraction means it's negative.
Yeah.
Addition means it's positive.
Because I never saw it that way. I just saw it as
Oh, I
just
see.
saying something.
All right, I'm with you.
then you divided 1950 by 5?
Like,
No. Come on now. How do you solve this equation? I want to get h by itself.
Oh, 13.
Divide by negative 13. Yeah, and that's how we got this. So the idea of solving equations cannot change. But now we're seeing where they come from. Where could equations come from? Frickin' anywhere, right? So once I get it set up, I should know how to solve it, because that process never changes. It's just where it comes from that changes.
So how would you graph this then?
Yeah, I wouldn't ask you to graph this one, right? Yeah.
yeah.
Yeah, the graphical method we pretty much give up on kind of quickly, because most equations that come from word problems are going to have kind of gross y-intercepts or gross slopes or something. And that was the major failing of graphical method. If the answer was supposed to be 1.5, I'm probably not going to see that at my freehand graphing, am I? No. So thank God algebra comes in and says, I got you.
Like if you did that, you need like a really precise, like.
You'd have to have a
graph.
remarkably precise graph. You'd have to have straight edge, and even with a straight edge, I still kind of like don't get it straight. Anyway, okay. What's up? Oh yeah, we're working up to that. Wait until we get there. Yeah.
Yeah,
Yes.
I came up to that. So it's,
Hey, come on now. What are these doing to each other? What's the operation here?
multiply.
So how do you get rid of this? What's the opposite of multiply?
Oh, positive.
No. What's the opposite of multiply?
Oh, divide.
Divide.
Divide by
Negative 13.
13.
Yeah. So you gotta stop your brain. Your brain's gonna go, I got you. Positive 13 is the opposite. And you're like, stop it. I'm not the opposite of the number. I need the opposite of the operation. Okay. So, on that handout I gave out last time, anybody need that? This is the one where it's got 5-3 on one side and it has an airplane problem at the top.
Oh.
So we need that.
Yeah. No, I don't need it. I have it.
Yep.
I like the second problem. I really do. Put this guy in the cheap seats
Seem
here.
like a very,
What's up? Sorry?
I'm glad that the farmer notices the legs we can't count is.
Yeah, I know, it's a little bit. Oh, well. Alright. Oh, there you go. So guys, look at this first one. This is a problem we did in the past, but we did not do it using multiple variables because it was a little too soon, but come down here, there you go. Airplane has 150 seats. The number of coach class seats. So what do you want to call this?
C.
See.
What? Huh? X, sure.
Smiley face.
Wait,
Make smiley face.
so first class, no. Come on guys.
No.
You ready?
Coach.
I'm gonna do this for you. I'm not gonna take any more suggestions. Coach class seats, let's call it C. Okay, was it? First class seats, let's call it F. Right, let me zoom out here a little bit. So we are now able to do these problems using multiple variables. We've learned how to deal with equations with two variables. So there's 152 total seats. There's almost always going to be an equation that's like a total number for some of these things. I like that. 60% of the time it works every time. For some of these, almost always, anyway, isn't there a total equation? 152 total seats. So what's that equation look like? That's the easy equation.
C plus F equals 152.
C plus F equals
152.
152. I like it. And the second equation is just coming up from this. The number of coach class, C, is 5 more than 6 times F.
5 plus 6F.
Either way, it doesn't matter. You can add whatever order you want to. All right, let me stop there for a second. So this is, we would have seen this problem earlier this semester. We would have just used one variable to solve it. But now we have expanded our knowledge base, and we can go like this. So what is this set up to be solved using?
Substitution.
Hell yeah, it's already solved for C. So I can rewrite the first one, how?
6F
6F plus 5
plus F
plus F.
equals 152.
Good, because that's C plus F equals 152, and then you can solve. Yes?
Isn't this just doing what we did before, but with an extra step?
Sort of, yes. It's like that earlier problem, just with extra steps. But in a way, some students are going to like this way better because it's kind of capturing the idea of the problem more directly. C plus F is 152. We didn't use to see that idea so directly. So yeah, you have to know how to do it both ways. This problem, though, is a classic one that's almost impossible to do any other way besides this. It just wants to be set up like this. That one you can do a couple different ways. So what do you guys get here? Whoa, we'll catch up to you. Oh, somebody did put, oh, I know, shame. Put your name on here before. What are your questions? 7F subtract 5, right?
Yeah.
Is 147. 21. Thankfully, F goes into that. Good. 21 what?
Seats.
What kind of seats?
First class.
First class seats, which means how many coach seats?
131?
Yeah.
Yeah, you get 126 plus 5, 131 coach seats, coach class seats, whatever the hell. How do you check that?
Yeah.
You add them together.
What's 131 plus 21?
152.
52, yay! There you go. All right, look at number 2. All right, I know some of you guys have done these already, just kind of hang out. Stop overachieving. No, it's fine. You can do that. Do you have that? Oh, yeah, you got it. Oh, okay, you're good. I just want to make sure you had it. This one's kind of, I'm a little worried about this farmer. He's fixated on
Legs.
animal legs. I don't know about that. Mm-hmm. Talking about sleeping, you walk around, God, wow, I shoot two animal legs.
Yeah, who counts animals by legs? He's just like lying on the dirt. 1, 2,
Pretty much this guy does.
3.
He's afraid to go in the little pen, so he looks underneath. All he sees are legs. I don't know.
Don't know what those ducks are. Are they kept in the same pen, the ducks and the cows?
Like potatoes. Huh?
Are the ducks and the cows in the same pen? Doesn't
For
seem.
my situation, they would be. And again, this guy's weird, so.
And he's a farmer, and his whole farm is only 24 ducks and cows, and nothing else.
Didn't say he was a successful farmer.
You get a farm, and then you start talking about this poor guy in this situation. Okay. What are my variables that represent?
Ducks and cows.
Ducks and cows.
What about them?
Their
B
legs.
and C.
The number of, right?
Oh yeah.
Alright. So what do you, I'm just gonna, so D is the number of ducks. That's amazing. C is the number of cows. You could use M for meat cows.
And Q for quack ducks.
Exactly.
Yeah.
Let's see. Do you see an equation that represents a total?
D plus C equals 24.
24 animals. So that's the straight up D plus C is 24. Is that cool? Almost always, for some of these, there will be an equation that totals up. It's just all the letters added make something.
Yeah.
You can see that a decent amount. Not always, but almost always. And then what's the second one has to deal with legs. So how many legs does every duck have?
2.
2.
Oh, good, I'm glad. You do have to know some minor biology. Some four-legged ducks. I don't know. So every duck gives 2 legs, and every cow gives
4.
We are assuming they are all healthy and they haven't had any
Problems and
issues,
complications.
amputations. They were born with an extra leg or something.
Lost a leg.
Actually, half of them were born with an extra leg, but the other half had their legs cut off.
Yeah, and just whatever happens, it worked out.
Whatever happens,
It worked out.
And was exposed to radiation, had an extra leg.
Cows, as all things should be.
Ate somebody else's leg.
The cows.
Let me stop,
legs.
sorry.
No, not
Is there where you see where those equations came from? And some of you guys might notice that in a sense they are easier to set up than the way we were doing word problems before with just one letter. Right? They kind of set themselves up a bit. And this one you gotta be careful, it's legs, so you gotta have that extra dimension of realizing it's 2 and 4 and all that kind of stuff, but still they sort of set themselves up. If I do this using substitution, how would you do that?
Subtract C.
Solve for C.
Sure. All right, I love it.
Yeah.
So the first thing I heard was to subtract C, so to solve for D, so I'm going to do that. So I can rewrite this as D is 24 minus C. Right, I solve for one of the letters in one equation, and then I use that information in the other equation. So 2 times D, but D is 24 minus C, plus 4C is 62. I really hope everybody gets that. I wrote the same equation, I just replaced D with what it is.
But since it doesn't say like a specific method, could you do elimination?
Yeah, I just want to do these two with substitution. These are kind of like at the tail end of the substitution we did, and then elimination starts. So we'll do those equations with elimination. So I will be specific in a few places on the test, and then there will be at least one problem where you can pick a method to solve. You guys sort of, so you got to know how to do both. Don't just focus on your favorite one. All right, and this, I'm just going to plow through this. So 48 minus 2C plus 4C is 2C. Subtract 48, divide by 2, you get 7. Anything out?
8.
8? 7. Subtract 48, you get 14, divide by 2 is 7. So that means what? 7 cows. So how many ducks?
How did you get 62 though? It's 64 legs.
64? No,
62.
it's not.
62.
No, it's 62, is it?
Yeah.
I just can't read.
You got the 24, I'm with you. I understand.
It's okay.
That's the evil thing about this. That's why you should be very happy that you have a teacher that gives you partial credit. you're gonna get like half of or no, I think it'll come out. Well, how many ducks are there then?
17.
Yeah, 24 minus 7, there's 17 quack mice.
There's not a bunch of ducks.
It's a duck farm. It's a cow.
Then what are the cows?
Cows are for the milk. There you go.
For the ducks?
I guess so. No, that's
What a weird farm.
And you have the beetles come out here. Alright, sorry I brought that up.
Open up this can of worms again.
Last couple things. These, so last time we did these by elimination. On the front here, we did these by elimination. I want you to do this one real quick, using elimination.
I forget how to do elimination.
Focus, focus, holy crap.
No, that's not the thing.
There we go.
the machine.
I like this though, so you guys can see this.
Quick question to everybody. Does anybody remember how to do elimination? Great, awesome. Just wanted a gut check to see if everyone has not this. I just wanted to check for you guys.
I like this. When I focus, it gets focused data.
Remember, you gotta cancel them out, so like a negative 2x and a positive 2x.
So stay out of it.
Yeah, you're right.
So, for example, if you forgot how to do elimination, these first two were set up so that a letter would die when I added the equations together. We talked a little bit last time about why you're allowed to add two equations together,
Yeah.
so I'm not going to say that. This one, nothing would cancel when I added them, so I had to multiply the first guy by -2, for example. Was it the first guy or the second? What do we do here? Oh yeah, you multiply the first guy by -2, so it became -4x minus 8y equals -10. Then the y's died, right? And the x's happened to die. So, this one has an obvious, letter you want to kill, because it's easier. I would say kill the x. You try to kill the y, you have to do both of them to make the 9 and 6 become something that they agree on. But the x, I can make it become -2x easy. You guys see that? If I add those together right now, nothing cancels, so I achieve nothing. Good job. But if I multiply the first one by -2, then the x stuff would cancel, and I could solve for y. That's the whole idea behind elimination. Yeah.
So, for the answer for number 4, I got like -1.
Let's find a third. So if I do multiply the first one by -2,
So divided this by -4.
so you get -2x minus 18y equals -2. Let's see what we get. So these die.
Yeah.
-24y equals 8. So y equals 8 over -24, right? Which is -1/3. Is that an ideal number? No, but notice something. You see why you shouldn't freak out? What's in front of the y's in the equations?
Multiples of
Multiples
3.
of 3. So when you plug that value in, it's not going to be a fraction anymore. See, don't give up immediately. Give it a minute and then give up on it. Still don't give up on it. This one is nicer. Even if that didn't happen, you have to be able to handle fractions. Come on. But that is a nice part of that. So which equation do you want to plug into?
So we can plug it into either equation.
Either one. Because what's the idea behind this? When I solve a system of equations, I'm always finding where the two lines meet. So it's the point they agree on. So I don't care which one I plug y into, it's going to come out to be the same x because they have to agree on that point. You guys with me? So if you did plug it into both, you would get the same value for x if your y value is correct. So it actually is a way to check it. So let's do that first one, I think. All right, we'll take the first one. X plus 9 times y, but what's y? -1/3. So I get x minus 3 equals 1. So I get x is 4. Is everybody cool with that? Right? You see the 3 went into 9, blah, blah, blah.
So the point is
Yay.
4 comma negative 1/3.
I like it. So you could leave it like this, or you could write it like this. Yes.
And if you wanted to make it like a not bad point, could you do anything to that? Like, could you multiply both the x and the y by 3?
Then the point moves, and then it's not the right point. You see what I mean?
Yeah.
That's the point where the lines meet. If I did anything to those two coordinates, it would be a different point, and they don't meet there.
Okay.
Cool. I like
Keep
it. All right. So what about this one? There's no escaping what you have to do here. But which letter? Notice how the y's are already what?
Opposite.
Opposite signs. I know the x coefficients are smaller, so that could be an argument, but you have to multiply one of them by a negative. And anytime I introduce negatives into my process, I open up a possible area I can make a mistake. I'm damn good at math. I have no qualms saying that because there's very few other things I can actually say that sentence for. I'm really good at math. I still won't do that because I know I'm a human and I can make a mistake with a negative more often than not. So I'd rather go ahead and do the y's. They're already different signs. I don't have to introduce a negative and have another place to make a mistake. It really doesn't matter. If you wanted to kill the x's, if you multiply the first one by 2, you have to multiply the second one by -3. Do you guys see that? To make the x's have opposite signs. Because what's the whole point of elimination? I want to set it up so when I add them, something cancels. So if I do attack the y's, what do I multiply the first guy by? If I do attack the y's,
By 5?
I'm going to multiply him by 5. If I was attacking the x's, I agree, you could multiply by -2. So when I multiply him by 5, I get,
negative.
I wrote over that, now I
Short
can't see
circuit.
what it says. Yeah, 15x minus 20y equals, what's 5 times 22?
10?
1 cent. Yeah. And if I multiply the second one by, because what's the LCD of 4 and 5? 20.
No.
So multiply the first one by 5,
20.
multiply the second one by
4.
4. So then you get 2 times 4 is 8x, 5 times 4 is 20y, 16 times 4 is
64?
64. So the y's die. Not a surprise, we set that up to happen. And then here I get 3x, thanks everybody.
Negative 56?
There I get, what is it?
Negative 56.
56.
Oh.
No, 46. There it is. You can do it, Jeff. Good job, bud. And then, not even Steph Curry makes every shot. Divided by 23, you get
Negative 2.
-2. So then how do you get the y?
Plug it back in.
Like back. Where?
I don't know.
I like it.
The bottom one. Top.
Either one.
Yeah.
Whatever you want to do. So if I do the top one, just because I have more room up here, 3 times x, but I know x is -2. -6. And then I can solve, that's -6, when we add 6. Divide by -4, I get y is -4.
Negative 16 divided by -4 is
Positive 4. Thank you. Yeah. Yeah, exactly. So here's somebody who killed the x's instead, and she got the exact same answer, of course. It doesn't matter which variable you kill, you're just going to find the other variable's value first. So if I would have killed the x's first, I would have figured out the y value is 4. I would have done that first. Yeah.
Alright.
Yes.
I still have a problem with like the meat of the equation, which is how did you get like the 23 in the
Oh, so I'm kind of glad you're saying that. You can't, so for some reason I get people that write these two things, and then they'll write like 8x equals 64. They think that just by putting these together, the y's pop away and no. How do I kill these? I have to do what to the equations? I have to actually add them together.
Yeah.
So what's 15x plus 8x?
Oh, 20.
What's negative 20y plus 20y?
0.
And what's negative 110 minus
That one.
negative 46?
Oh, when they're like, when you're finished with it, you add them instead of. Okay.
That's the only way that the things you set up to cancel will cancel is if you add them together.
Because like I mixed up a lot of things when I was remembering stuff differently.
I got you. It's always possible because we have a lot of shit going on.
Like, cause I understand the beginning and then I mix up stuff in the middle
I'm
and
with
then the ending is.
Yeah, but you can't just put them close to each other and they pop like bubbles. I always see people do that. You have to actually combine them for that to happen.
Yeah.
All right, one last problem, then we'll head out.
You do the number one of the bank?
The which one? The bank? Yes. Sabrina, teenage witch. Reboot was really good.
Is it really?
Have you seen the TV?
Dude,
I heard
I
it was
was
really, really good.
skeptical, and then I saw a little teaser, and then it gets really dark. It's pretty cool.
Okay.
Anyway, unless you don't
I
like
watched
dark,
it.
then don't watch it. Yes,
Yes.
that was really good.
It was good?
Or you gotta watch Happy if you want to get into that place.
I love it.
Happy takes so much ass. There's part 2 coming up. It's the second season. Anyway, I'm sorry.
Wait, hold on, what's happening?
It's somebody's imaginary friend, somebody else can see it, and the imaginary friend helps him.
Oh,
Is it on Netflix?
Find the bad guys.
Is it on Netflix?
Yeah, it's one of my favorite actors.
I'm
All right,
not gonna look
enough of
it
that.
up.
I'm sorry. I'm being a really bad teacher. So you guys are gonna complain to me later. Guys. So, this person goes to a bank, gets change for a $50 bill, consisting of all fives and some, and $1 bills. There are 22 bills in all. All right, this is exactly the kind of problem I hate, but hopefully you can see it's just practicing the process. Hopefully it's not a person like this that it's like, I can just, I don't know. Yes. Okay. So, again, this doesn't always happen, but very often it will. First off, what are my variables going to represent?
The dollar bills.
Kind of bills?
Be more specific. So,
$5 bills.
$5 bills is column what?
F.
Dollar bills, yo. So, okay, 5. We'll call it F, sure. You can call it X, you can call it A, you can call it whatever you want. What about $1 bills?
Oh.
O. J?
Call them
OJ.
N. Oh, shit.
Okay.
Oh, I love this bit. All right. There are 22 bills in all. This is the